Imagine an AI that discovers new medicines in days instead of years, an AI that predicts hurricanes weeks earlier, or one that cracks today's strongest internet encryption in minutes. Now, imagine giving that AI a computer that doesn't think in ones and zeros, it thinks in many possibilities at the same time. That's exactly what could happen when artificial intelligence meets quantum computing. Some scientists believe it could become the biggest technological leap since the invention of the internet, but others warn it could also become one of humanity's greatest challenges. So, what actually happens when these two powerful technologies combine? Let's find out. Artificial intelligence is already changing our world. It writes essays, creates art, drives cars, diagnoses diseases, but despite all its intelligence, today's AI still runs on classical computers. And classical computers have limits. Quantum computers are built on completely different rules. If AI is the brain, quantum computing might become its superpowered engine. And together, they could solve problems that today's fastest supercomputers would need thousands or even millions of years to finish. Artificial intelligence is helping quantum computers fix their biggest, oldest weakness. And quantum computers may end up helping AI do things it can't do today at any scale. This isn't science fiction and it isn't years away. Some of it is already published, peer-reviewed, and running in real labs. And let's start simple. Quick refresher if you haven't seen our last video. Your laptop or computer stores information using bits. A bit is like a light switch. It's either off or on. 0 or 1. Everything your computer does, from streaming videos to launching rockets, is built from billions of these tiny switches. Now here's where quantum computers become strange. Instead of bits, they use qubits. A qubit can be 0, 1, or surprisingly, both at the same time. This bizarre property is called superposition. Imagine searching for your lost keys. A normal computer checks one room after another. Living room, kitchen, bedroom, garage. A quantum computer is more like having millions of copies of yourself searching many possibilities simultaneously. That doesn't mean quantum computers magically know every answer, but for certain kinds of problems, they can explore enormous numbers of possibilities much faster than classical computers. And that's only half the story. Qubits can also become mysteriously linked together through something called entanglement. When this happens, changing one qubit instantly affects its partner, even if they're separated. Albert Einstein famously called this phenomenon spooky action at a distance. Scientists have repeatedly confirmed that quantum entanglement is real. And together, superposition and entanglement give quantum computers a genuinely different way of tackling certain kinds of problems. Not faster at everything, just fundamentally different for a narrow, specific set of tasks. Artificial intelligence learns by processing enormous amounts of data. Think about ChatGPT, Gemini, Claude, or self-driving cars, or image generators. They study billions, even trillions of examples. Training today's largest AI models requires enormous numbers of mathematical operations, mostly a type of math called linear algebra, done over and over across billions of parameters. That takes enormous amounts of energy, enormous numbers of chips, and enormous amounts of time. And some problems AI would love to solve, like simulating how molecules or materials behave at the atomic level, are so complex that classical computers simply can't brute force them accurately, no matter how much hardware you throw at it. Classical computers become a bottleneck, so demand for computing power keeps growing. That's exactly the category of problem quantum computers are built for. Imagine trying to empty an Olympic swimming pool using a teaspoon. No matter how fast you move, the tool itself limits your speed. That's why researchers are exploring quantum computing. not because it replaces classical computers, but because it may solve certain incredibly difficult calculations much faster. Instead of making AI merely faster, it could allow AI to solve problems that are currently impossible. This is where quantum machine learning comes in, using quantum computers to help train or run AI models. The idea sounds simple. Instead of using only traditional computers to train AI, what if some of those calculations were performed on quantum computers? In theory, quantum computers could explore many possible solutions at once, allowing AI to process certain complex mathematical problems much more efficiently. Researchers believe this could eventually help with finding hidden patterns inside enormous data sets, creating more accurate scientific simulations, designing new medicines, improving financial forecasting, even helping robots make better decisions. Around the world, scientists are already experimenting with quantum versions of neural networks, quantum support vector machines, and other quantum enhanced learning algorithms. Companies like Google, IBM, Xanadu, and several universities have published encouraging early research. It sounds revolutionary, but here's the part many headlines leave out. None of this has yet beaten the best classical AI systems in real world commercial tasks. Today's quantum computers simply aren't powerful enough. They contain too few reliable qubits. They're extremely noisy, and they make errors far too often. So while quantum machine learning is one of the most exciting research fields in computer science, this is promising active research, not a working product, not the future you can download next year. So if quantum powered AI isn't running your apps yet, what's actually happening today? But something even more exciting is already happening today, and it completely flips the story upside down. The part of this story is arguably more important than the flashy version. It's just running in the opposite direction. Instead of quantum computers helping AI and making it smarter, AI is helping fix quantum computers' single biggest problem: errors. Remember from our last video, qubits are incredibly fragile. They're sensitive to almost everything: tiny vibrations, stray electromagnetic signals, even tiny amounts of heat. Any disturbance could cause a qubit to lose its quantum state. Scientists call this decoherence. To make a quantum computer reliable, engineers group many physical qubits together into a single logical qubit and constantly check for errors. But figuring out exactly which qubit failed and how to fix it in real time is an enormous pattern recognition problem. In November 2024, Google DeepMind and Google Quantum AI published a system called Alpha Qubit, a deep learning neural network trained specifically to detect and correct quantum errors. Researchers trained it using hundreds of millions of simulated quantum errors. The results, published in the journal Nature, were genuinely impressive. Alpha Qubit reduced errors by about 6% compared to the best existing precise method, and by about 30% compared to the faster method typically used in practice, tested on configurations with up to 241 qubits. Those numbers may sound small, but in quantum computing, even tiny improvements matter enormously, because every reduction in errors moves scientists one step closer to building large-scale, fault-tolerant quantum computers, which in return shortens the timeline for quantum computers to become powerful enough to tackle the big problems: drug discovery, material science, optimization, that we talked about last time. In other words, right now, the real working relationship between these two technologies runs backwards from what most headlines suggest. AI isn't just waiting for quantum computers to become useful to it. AI is helping quantum computers get there. There's a second, quieter way AI is shaping quantum computing, helping design the hardware itself, building better qubits, better circuit layouts, and better calibration routines. This involves searching through enormous numbers of possible configurations, and modern AI is good at this kind of complex, pattern-heavy search problem. Research teams are increasingly using machine learning models to help calibrate quantum devices, tune control signals, and even suggest new physical qubit designs, shrinking a process that used to take weeks of manual tuning down to something much faster. None of this replaces the physicists and engineers doing the work. Rather, AI acts like an incredibly fast research assistant. AI is accelerating quantum hardware development today rather than a distant future promise. So here's the honest picture of where this is actually heading, not the exaggerated one. In the near term, the next few years, we expect more of what we just covered. AI is making quantum hardware more reliable, faster to build, and easier to calibrate. That's the unglamorous part of this story and is most likely to actually happen on schedule. Now, further out, imagine a future where quantum computers become reliable enough, not hundreds of qubits, but millions of error-corrected qubits working together. What might AI be able to do then? One of the biggest possibilities is drug discovery. Instead of spending years testing millions of chemical compounds, AI could use quantum simulations to predict how molecules behave before they're ever created in a lab. That could dramatically speed up the search for treatments for diseases like cancer and Alzheimer's, or antibiotic-resistant infections. Another possibility is designing entirely new materials. Imagine batteries that charge in minutes, solar panels that capture far more sunlight, or lightweight materials stronger than steel. Quantum simulations could help scientists discover materials we've never imagined. Then there's logistics. Every day, millions of airplanes, cargo ships, delivery trucks, and supply chains must be coordinated. Finding the absolute best solution becomes unimaginably complex. Future quantum-enhanced AI could optimize these systems far more efficiently, saving enormous amounts of fuel, money, and time. Climate science could also benefit. Researchers could build far more accurate climate models, helping governments better predict extreme weather and improve long-term planning. But perhaps the most fascinating possibility is one we can't even predict yet. History has shown that every major leap in computing eventually leads to inventions nobody expected. The internet, GPS, smartphones, modern AI. None of these were obvious when the underlying technologies were first invented. Quantum computing could follow the same path. So to answer the question directly, right now, quantum computers and AI aren't merging into one super technology overnight. What's actually happening is quieter and in some ways more interesting. AI is helping solve quantum computing's oldest problem, while researchers lay the groundwork for a future where the reverse becomes true too. Whichever direction ends up mattering more first, one thing is clear. These two fields stopped developing separately a while ago. If you want to understand where computing is actually headed, you can't watch just one of them anymore. If you haven't seen our video on what quantum computers actually are, click the video on your screen now, because once you understand how quantum computers work, this entire story becomes even more incredible. If you enjoyed this deep dive into the future of technology, don't forget to like the video and subscribe. Until next time, stay curious.